Hello girls, this is my 14th lecture on numerical analysis for 5th Sem DSC students. I Miss RANJANA DUTTA from the Department of Mathematics of Graduate School College for Women. Yesterday we studied um, bisection method. Today we are going to study the method of false position under the algebraic and transcendental equation. So bisection method and this method, that is the method of false position, are very similar. In bisection method, we calculate x1 as a plus b by 2, starting x1 as a plus b by 2, but in bisection method we take x1 in the method of false position we take x1 as a into fb minus b into fa divided by fb minus fa. Other than this, all the calculations are similar, very similar. So here, take one example and see in this example, find a root of the equation fx is equal to x cube minus 2x minus 5 is equal to 0. We find f2 is minus 1, that is negative, and f3 is 16. Using this formula, a fb minus b f1 fa divided by fb minus fa, and fx is given. We find that f2 is minus 1 and f3 is 16. Hence, a is 2 and b is 3, and a root of lies between 2 and 3. So root lies between 2 and 3. So we calculate x1, that is equal to 35 by 17 is equal to 2.0588, and so on. So we calculate fx1 using the formula, and if we calculate fx1 we find it negative, whatever written, and hence the root lies between 2.0588 and so on, because this f1 is negative and the positive is 3. So the root, next we have to calculate the root between 2.0588 and 3. So similarly, from using the formula we find x2 and we get it is positive. So fx2 is again negative. It follows that the root lies between 2.08 and again at 3. We are shifting our position from more negative to closer to the point of where the root lies. Now x3, again we calculate x3 and it is positive. Proceeding in this way, we obtain x4, x5, x6 and x7. In proceeding this way, we can say that 2.09435 is very similar to 2.09446. So hence the root lies between these 2 points. Again, we are going to study today the Newton-Raphson method, which is different from these two methods. So Newton's Raphson method. In this method, generally used to improve the result obtained by one of the previous method. Let x0 be an approximate root of fx equal to 0, and let x1 is equal to x0 plus h be the correct root of fx1 is equal to 0. Expanding this by Taylor's theorem, we can write it as fx0 plus h is equal to fx0 plus h f dash x0 plus h square by factorial 2 f double dash x0 and so on. Neglecting the second and the higher order derivative, we can get fx0 plus h into f dash x0 is equal to 0. From this, we get h is equal to minus fx0 by f dash x0. A better approximation than x0 is there given by x1 is equal to x1 minus fx0 by f dash x0. Similarly, xn plus 1 can be written as xn minus f xn divided by f dash xn. So now take xn plus 1 as phi xn. So phi x can be written as x minus fx by f dash x. Now phi dash x differentiating with respect to x, we will get this is equal to fx into f dash x divided by f dash x the whole square. Now, putting these values in Taylor's theorem, we get fxn plus zeta minus x0 f dash x0 xn plus half zeta minus xn the whole square f double dash xn so on dot dot up to infinity is equal to 0. From this, we get the calculation given on your screen. Now, geometrically, the method consists of replacing the part of the curve between the point x0, fx0 and the x-axis by means of the tangent to the curve at the point, and is described graphically in figure as shown. It can be used for solving both algebraic and transcendental equation, and it can also be used when the roots are complex also. Now, take one example again. Fx is equal to x cubed minus 2x minus 5. F dash x is equal to 3x square minus 2. Hence, putting these values in equation 2.24, we get xn plus 1 is equal to xn minus xn cube minus 2xn minus 5 divided by 3xn square minus 2. Choosing x0 equal to 2, we find fx0 is equal to minus 1 and f dash x0 is 2. Putting n equal to 0, we obtain x1 is equal to 2 minus 1 by 10 is equal to 2.1. Now, fx1 can be calculated. Similarly, f dash x1 is calculated, and x2 we get the value of x2. Take another example. Find a root of the equation x sin x plus cos x is equal to 0. So fx is equal to x sin x plus cos x and f dash x is equal to x cos x. Then we will know that xn plus 1 is equal to xn minus fxn divided by f dash xn. So now take when x0 is equal to pi. The successive iterative are given below. n0, 1, 2, 3, xn we have to calculate it. So first xn will be get when we put n is equal to 0, and then it gives 3.1416 and fx0 is minus 1.0. Similarly, the value of xn plus 1 is 2.8223, and replacing these values with in x n column second time second row, that is 2.8223, and we get fxn, and that is minus of this is equal to 2.7986. Then 2.7986, when calculated fxn, we get minus 0.0006, and xn plus 1 is 2.7984. Then 2.7984, when fxn is calculated, it gives 0. That is when the values changes from negative to positive, then we get the value of the root of the equation. Here it is 2.7984. So 7984 repeating twice, 2.7984. So we can say that the root lies near to 2.7984. So students, this much only for today. Thank you.